and how do I support model training for different AI? Because if everyone uses the same AI, what is really differentiating you from competition, and so forth. So, in the initial demo, I show you the ways of RAG. I introduced retrieval augmented generation process, RAG. It is the process where we store new data in a database and then enable large language model to read from that database while he's retrieving his responses. So we are augmenting his retrieval process with the new data. For this process, I have created a pipeline. Again, we want to have this in a reproducible, repeatable process. And the pipeline has a couple of components. So we start by reading the documents. So each organization has a bunch of enterprise documents. These documents come in PDFs, Word files, you name it, all the formats. So we need to have these domain documents, this proprietary document stored somewhere, and that is the easiest way to store them in an S3 storage. As I said, I'm using mini IO, but this could be an S3 bucket on Azure, Ceph, on-premise, whatever, doesn't matter. So we're first going to read from that storage which documents are there. And then we're going to use a special large language model called DocLink. And you might have heard about DocLink. DocLink is a fully open source coming from IBM. And it's a large language model specialized in transforming document formats. It is specialized in transforming things like the business Word documents, business PDF documents into machine-readable JSON and YAML files. What makes it special around DocLink? Because there are many models that can take a picture of a document and then translate it to text. DocLink is able to keep the complex document formats in line. So he's not only blindly translating picture to text, he makes sure that he follows what is the title, what is the subtitle, what is the context, how is this paragraph broken, where is the table, what are the mathematical formulas. So it is really specialized and trained on understanding what is in a business document and extracting it in the best possible way so that you are not getting a broken document and injecting unrelated pages into a vector database. I hope this makes sense. If it doesn't, please ask me. Because what I have seen, you have a document, you have a section that is on 2 pages of a document. And as a human, I read it from left to right, and I know when I end on this page, I continue on the next page, and for me, the context continues. So for human, that's not the problem. If I would give these 2 pages to a model and say, translate this to text, he will translate that to text, but without keeping any correlations between these 2 documents. For him, are 2 different images, right? And if that text is broken, like the white papers are broken into multiple lines on one document, multiple paragraphs, you can get very confusing output of text from that image. Model is able to extract the text from the image, but in a very ununderstandable way. And when you take that and now transforming it into the vectors for the embedding into the database, well, it easily gets a mess, complete mess. It doesn't keep track what text is correlated to what, so it's unused. So DocLink is really helping to solve that, to have a contextual aware transformation of text to the format. So DocLink is the star here. It works purely CPU. You don't need the GPUs for this model. You can add the GPU if you want, but if you have only CPU, it runs on purely CPU. So the DocLink is processing these documents, and I have used documents like I loaded the full OpenShift documentation PDF. I loaded next to the documentation, I loaded a full book, 350 pages, OpenShift DevOps handbook. It sucks it in. Those 2 documents only CPU, 20 minutes processing. If I had GPUs, if I had more resources, I could make it even faster. But for me, this was also acceptable. Other use case I took, for example, EU AI Act, a very complex legal document explaining the legislations or the constraints of AI. I loaded it in, and I can now chat with the document and say, explaining the EU Act to a platform engineer and so forth. It can go all kinds of things. So different documents, you have a pipeline, you run it, it processes that. This is an IBM embedding model because Docking will, as the result, give us the YAML files or JSON files. And then we have to take those files and break them into something called embedding chunks. Again, a new terminology. But because large language model, he only reads the numbers and the correlation between the numbers. Everything needs to be translated into the number vectors. And that's what this guy, here is a model that takes the text and then translates the text into the number vector representations and then stores that into a vector database so that it's ready for querying by a large language model. There are multiple embedding models available. This is an IBM embedding model that we use. And Milvus is a vector database, but there are other vector databases available. Milvus is an open source one. Postgres PG vector is another one. Elasticsearch could also be used as a vector database and so forth.
The point is to like my network share. Or is that a bad idea? Like pointing it to a network share, for example. Like a company that work as a big network share with a lot of documents.
Of course, that could be the input instead of S3 storage, right?
Yeah, but I think if you add too much, then it might come up with bad stuff, right? If you add too much input.
Of course. Don't, yes. Sort it out. Be able to reproduce, to test it, because.
Can you use AI to sort it for me? Like make in the pipeline, make it decide if this information is relevant to duplicate.
Yes, but it's not one click. You would have to have a process of cleaning up your data. So we could have an AI that goes and reads and gets classifies your document based on some additional metadata, and then we use that metadata to see the relevance of those documents and so forth. So there could be a process to help you cleaning it, but there will be some coding involved, some logic involved. But you could point it to a SharePoint, to a Google, whatever, Dropbox. What is good is because data is becoming, data is going to be injected into your model. So with each new injection of the data, you get a new version of the model. I also suggest versioning that data segments that you are injecting, so that it's better, what I want to say, it's better to have small groups, small batches that you process, inject, test, validate, and then inject a new one, than having a big bulk and then you don't know what went good, what. So it becomes part of an incremental process. So here a slide around the docking. Multi-format parsing, support PDF, Word, PowerPoint. It also supports audio to text. So if you have organizations that have a lot of call center recordings or those kind of things, we can load those as well, transform them into the YAMLs, and feed them into our models. That would be also a use case. Kubeflow. So the pipeline that I have shown you is implemented in the Kubeflow. What is Kubeflow? Anyone heard about Kubeflow already?
Yeah, heard about it.
For me, the Kubernetes native machine learning platform that supports the full AI lifecycle. How I explain it to someone on a very, very short way is say, this is Jenkins for machine learning. We are used to Jenkins as the CI/CD component, GitHub Actions, Tecton pipelines. This is a CI/CD server for machine learning use cases. What makes it different? Because it is native to the Python dependencies and the packages. It has a native integration, Python, PyTorch, PyLibraries, everything that you would have to build custom images in other tools. So think this as your Swiss knife for the machine learning automation workflows. And it's not one or the other, you can still mix and match technologies. I can explain you that later on. I don't want to overcomplicate it. But the Kubeflow Jenkins for machine learning. This pipeline is created in the Kubeflow, orchestrated in the Kubeflow, and monitored in the Kubeflow. And these are also the developer environments, Jupyter notebooks. So, for example, I wanted to show you. Where's my project? Data science project. So, I'm having the pipelines here, I'm having my models here, and I can also have the workbenches. And the workbenches are the integrated developer environments. We are having at least two flavors of the workbenches, the Jupyter notebooks, which are more traditional Python development environment, and we have the VS Code servers that can do both traditional development and the Python environment. It's just a preference which interface you choose. In this case, this is a Jupyter notebook. I'm connecting it to the Git repository, and from the Git repository, I'm having all kind of runtime of playbooks, notebooks to evaluate, to try different things, to code, to iterate over my model. For example, when I was preparing those benchmarks, those evaluation tasks, before I integrated them into the pipeline and automated them, I use them here in my notebook to test them out. So I'm testing here, these are the evaluation tasks. So I test a couple of those. I selected these tasks, this is for reasoning, this is the common sense task, this is the truthfulness task. So I tested a few of these evaluations one by one, then I said, okay, this looks good. Let's integrate this into the pipeline and automate this in the process. But you can also use this. For example, I'm doing the docklink processing. So I first tested docklink by calling it from the Python code to see how it processes these complex documents, to see if I have to do any tweaks, any configurations. Once I was confident with that, then I baked it into the pipeline and make it repeatable. If you are building predictive models, machine learning models, then you're going to spend a lot of time here in the notebooks. So the workshop that I'm going to share with the audio with some of you later on, we have created a fictional parasol insurance company, and for that insurance company, we are integrating machine learning and artificial intelligence in the process of managing the claims, process of claims, insurance claims. In that case, we are using a lot of notebooks to build the different models and different components. So we can summarize the emails, analyze the pictures, all kinds of things. Then you are spending a lot of time. When you're working with agents, I would say less development in this one. Clear? Jupyter Lab. Okay, I'm going to go to this. So we are coming to the end, and we say, okay, now models is working. It shows our models. They are grounded in our data. I'm processing new data every night. So every morning I have fresh data into my model. Now, how do I integrate this? How do I secure this, and so forth? So here we are going to focus on embedding this trust observability. We are going to use something called the Llama stack for the application integration and API integration thing. And we are doing a lot of pipelines. So here, a Llama stack. As you have seen in the beginning, I showed you the demo when we used with the tools, and I had multiple MCP servers, so my model was communicating with different components and executing stuff for me. What I wanted to show is that to implement that, quite a few components into the place. So this is the topology view from OpenShift. Here I have those three MCP servers. So one is a Slack, one is OpenShift, one is querying the database. Here I have my three models, two Mistral models, one Granite model. Here I have my Llama playground, guardrails that I showed you, models. So what I want to say, I'm integrating multiple components into an end experience. I'm using here a Streamlit, but this could have been all orchestrated with the Java application or something like that. Like when integrating traditional services, we are connecting many APIs to each other. And these APIs are all evolving. The AI ecosystem is evolving constantly. The APIs are changing. The most stable API is the Open AI API, and it's also changing every month already. So to avoid that spaghetti code and that hassle that with every API change, I have to retest all these integrations, there is a technology called Llama Stack. And Llama Stack, you should think about it as a gateway plugin. So it provides a set of stable APIs so that I can plug all these components into one and have a less dependency on each other of them. So it gives me a stable API for a better integration and for a pluggable architecture. Because once I connect everything to the Llama Stack, I can easily swap out the model, any model. I can replace this model with another model without making any impact on these other integrations. That's why when you have seen, when I was working here, I can go here to the list, I change the model, and just pick a new model, while all the other integrations stay the same. So that is basically the Llama Stack. It is coming from the Meta company. It has the name of the Llama models, but that is the only resemblance with the rest. It is an API gate, it's fully open source, and from the Red Hat we are embracing it. We are seeing there are different things because there can be this on the server side and the client side. We think that the Llama Stack is the best component for the server side API standardization. If you go to the client side, then you could also use a Lang4j or a LangChain and those type of frameworks to manage your API integration. Make sense? Kind of.
Now, what do you need on the client side then?
Nothing.
Because I have understanding what you
need
need on the server side, but what?
On the client side, you don't need, because you can redo this whole integration on the client side, right? Because I could say, as a developer, I could say, hey, don't bother about Llama Stack, give me the endpoints of these models, and I'm going to do that all integrated in my Java application, right?
Yeah.
From the developer point of view, is that's feasible. But then from the orchestration, then I don't know anymore where this is integrated. And if I implement some guardrails or something on that is reusable, that is not affecting you. So I think for implementing some of the government, it's better to have it on the server side and make it reusable as is. It makes you as a developer also less work because you don't have to say, okay, give me the endpoint of the Llama Stack, and I communicate with the Llama Stack, and I have access to all of these things. While knowing that someone else has made them integrate and set up, someone else took that worry for me. But you could theoretically say, no, I'm not going to do that, I just need an API to the model.
In this diagram, you show multiple models, right? In OpenShift, are the models always loaded, or are they taking up like CPU or like memory, or can you spin them up on demand or something?
So you see that they are looking a bit differently from the other containers. So this is the representation of the containers in OpenShift. These are the regular containers. When I say regular containers, Kubernetes scales the containers from 1 to many. Right? The boxes one, these are the Knative components. In this case, we are using the Knative as the underlying serving engine. That means that if there is no load on this, it's going to scale to 0. If you want to do that.
Then your time to.
Depending. You have that flexibility, but you can also say, don't scale it. I want to have this warm, always warm, at least scale it to 1. So you have that's why we use the K-serve. K-service is the name here. So we are using the Knative component in order to be able to scale it to 0. It's possible. But again, they are not spinning up in seconds. They need some time to warm up and spin up when you need it. Trust the AI. So I told you in the beginning around those evaluations, model evaluations. When we look around the predictive models, model bias, model drift are the methods that you want to understand. For the large language models, evaluation frameworks, different benchmarks, this is all packaged in something called Trust the AI. This is an open source framework that we invest. So you can look at this. And it will provide you out of the box many of these evaluations and the starting points that you can use as is, but you can take any of them and try to make it your own. So take it as a custom evaluation that you make. Make evaluation for my reg use case, or I make evaluation for understanding who is Adnan real and so forth. And the Llama stack. And the Llama stack provides us this set of simplifies the build of unified APIs, and one of the stars is MCP. MCP is one of the APIs provided within the Llama stack. But we will also have APIs for the vector embeddings, for the telemetry, for the safety, for evaluations. We have this, I want to say stable APIs, but not even this stable completely. But it's more stable than the other APIs. Yeah. That's it, basically. I hope I have not overloaded you too much. You will still be able to have some sleep later. Any question?